Let's talk about trig substitution and completing the square. Now, how does completing the square work? Well, when I learned it when I was in high school, my teacher called it halving and squaring. Okay, so let's say that you had something that looked like this. You have x squared plus bx, like this. And the way that I was taught, what you're going to do is you're going to take half of b. So taking half of b gives you b over 2. And then you're going to square that. So you're going to have b over 2 squared. Now, you're not allowed to just add something to an expression whenever you want. So to keep it unchanged, you're going to actually have to subtract the very number that you just added. So the net effect is that you added 0. All right? But the great thing is that when you do that, this front part over here, this factors as a perfect square. Okay? So we want to use this halving and squaring technique on this particular example that we have here. All right, so let's complete the square for that guy. So we're going to start off with x squared plus 2x. I'm going to move the plus 8 off to the side over here. Move it way to the right. I'm going to take half of 2. Half of 2 is 1, and 1 squared is just 1, so I'm going to add 1, but then I'm going to subtract 1 as well. That way my integrand remains unchanged. Then this front part, as I described earlier, this part factors as a perfect square, so that's just x plus 1 quantity squared. And the rest of it, -1 plus 8 becomes plus 7. Okay, so let's rewrite our integrand now that we've completed the square. We're going to have 1 over square root of quantity x plus 1 squared plus 7 dx. So when I look at this integrand right here, this looks like x squared plus a squared to me. And the role of x is really being played by x plus 1 in this case. And the role of a is going to be square root of 7. And when we have something like x squared plus a squared, that's exactly the scenario where we make the tangent trig substitution. So we put in a tangent theta like this. Differentiating both sides with respect to theta, we're going to get, on the left-hand side, we're going to get a dx. On the right-hand side, we're going to get a square root of 7 secant squared theta d theta. Okay? So now let's make our substitution. When we make our substitution, this integral is going to become the integral of, we're going to have 1 over, you got the square root, and we're going to have rad 7 times tangent theta quantity squared plus 7. And the dx part has a rad 7 secant squared theta d theta. All right. So one thing I could see is I could simplify the part under the square root. So I'm going to have 1 over the square root of 7 times tangent squared theta plus 7. I could have moved that rad 7 out front because you just have a constant times the entire integrand, so I move that all the way outside. And I'm going to have a secant squared theta d theta here like this. Okay. At this point, what I want to do is I want to factor out a rad 7. I have a 7 and I have a 7 here. It's all under a radical. So when I pull that out of the integrand, that is going to become, I still have the rad 7 out there front from before. When I factor it out of the denominator, I'm going to have another rad 7 over here. And then that leaves on the inside just the square root of tangent squared theta plus 1. And then you have secant squared theta d theta. All right. So we can see that these rad 7s cancel out. We can use our Pythagorean trig identity and realize that this denominator piece right here is really just secant squared theta under square root, which basically makes it secant theta. Okay. So after simplifying, I end up with secant squared theta divided by secant theta d theta. This guy simplifies to just the integral of secant theta d theta. And this is one of the integrals that, we definitely memorized. That's equal to natural log, the absolute value of secant theta plus tangent theta plus c. Okay, now we're not done yet. We still need to convert back to x. So let's take a look at what our original substitution was. I think if we take this original substitution and we divide both sides by rad 7, what are we going to get? We are going to get tangent of theta is equal to x plus 1 divided by rad 7. Now we know that tangent is the opposite side over the adjacent side. So let's draw our triangle. Let's label the right angle and label the theta. The opposite side we'll label as x plus 1. The adjacent side is going to be rad 7. And when we try to find the hypotenuse, we got to use the Pythagorean theorem. We're going to get that the hypotenuse is going to be the square root of quantity x plus 1 squared plus 7, the rad 7 squared, which is just 7. So I kind of want to point out that this hypotenuse also showed up in our integrand over here. All right. So now we could just use right triangle trigonometry to write down our final answer here. So we're going to get natural log, absolute value. Secant is the hypotenuse over the adjacent side, so that should be the square root of x plus 1 squared plus 7 over rad 7. And the tangent was the x plus 1 over rad 7. And then we want to make sure we throw in a plus c. Okay, so this is our final answer. All right, everyone. I hope you enjoyed this video on trig substitution and completing the square. Take care, everyone.